So in the previous class, actually we have discussed about the how to represent the rational numbers on the number line. Okay, if any rational number is given, fraction is given, we can easily denote that. Okay, on the number line. But now let us assume that if any number is given as an irrational number, just like root 2, comma, root 3, comma, root 5, like this. Okay, as we know that irrational numbers never going to end. Non-terminating irutte, non-recurring irutte. Okay, as they are non-terminating and non-recurring, so definitely it is very difficult for us to represent this one. But we already studied about the Pythagoras theorem. Pythagoras theorem, what it says? AC square. Okay. So it means we do have the ABC right angle triangle. If ABC is a right angle triangle, then okay. So it says that AC square. What do you mean by AC square? Hypotenuse. Correct. So hypotenuse, square of the hypotenuse is always equals to BC square plus AC square. What do you mean by BC and AB? They are other two sides. Okay. It says that the square of hypotenuse is always equals to sum of squares of other two sides. Correct? So it means if I have BC equal to 1 centimeter, AB equal to 1 centimeter, what will be the measurement of AC? Root 2. Why? Because we know that 1 square is 1 plus 1, so it will be AC square, which is 3 but 2. If we need AC, it will be equals to root 2. It means if we draw any one of the right angle triangle which has 1 centimeter as a base, 1 centimeter as a height, then hypotenuse will be root 2 or indirectly irrational number. So we can apply the same principle to draw the irrational number like this on number line. We just have to draw a line. As we draw in a number line model, we all know that. Okay. When you are trying to draw the number line, we start from either from here 0, or if it is an integer, then we start from 0 here. Now we have to start from this middle point only. Okay. What we have to do now? We have to take a 1 centimeter length from the 0. So we'll draw it. So let me take 4 centimeter as a 1 centimeter to make it in a bigger manner. In a smaller. Okay. So what we do? So 4 centimeter. This is my 1 centimeter. Okay. Or the value, not 1 centimeter. Let us take this as 1 only. If I draw another 1 centimeter, but this has to be exactly 90 degrees. From this point, E point I will draw a 90 degree, but the length of this side has to be exactly 1 centimeter. If I draw this one, we are going to have the right angle triangle if I join these things. Let me name this one as A, this is B, this will be C. So definitely if this is 1, this is 1, value of this one will be 2. But you have to say that, sir, it is not on the number line, sir, it is above the number line. How to join it to the number line? And what are we just have to draw a arc from this O by taking the radius as OA. If you join these two, if I take this as a D, then AC and AD will be equal. Correct? Because those are radius of the arc or radius of circle. So now this point will be root 2. So it means we can easily represent the root 2 on number line. So then what about root 3, sir? Because we have 1 todi karala. You are able to take 1 here. Because 1 root 2 karala. It's not possible. How to draw root 3 then? So for that very easier, we all know that this is root 2. If I draw another 1 centimeter line from the same point when it ends by taking exactly the right angle, means 90 degree. If I join them exactly 1 centimeter, it has to be exactly 1 centimeter and it has to join this 90 degree point. This is 1 centimeter or value is equal to 1. If I join this one, another right angle will be created. Correct? You can name it as a D. If ADC is also on the right angle, where base is root 2, side is 1, so then it has to be root 3. How? If I observe here, is AC square, or here it is DC square in this triangle because DC is hypotenuse. So DC square will be equals to AD square. AD square is how much? 1. 1 square is 1 plus this one AO. We already found that is root 2. So if I square the root 2, root to the square, it means square and square cancel each other. Remaining is 2 plus 1 is 3. So then DC square will be 3. If I take DC only, this is root 3. Correct? It means this line will be root 3. If I wanted to again represent it on number line, then I would just take OD as a radius. Okay? And join it on the number line. What are you observing here right now? This point is the but root 3. So then what about root 4? Easier. Again take 90 degree from here, join it and take arc. So this makes a beautiful circle figure. Okay? This type of construction is generally called as Theodor circle. Theodor circle. Okay, right? Okay, make it root 4 and root 5. Root 4 and root 5.